So good morning guys, this is Hardik Jain and today we are going to talk about topic called as software testing. So let's dive deeper into it. Software testing. As we know what is software testing, you might be thinking what is software testing? And you might be hearing it from many days, some open in the software testing field and all those things. And recruitment is going on. So let's discuss what is software testing. Software testing is nothing but a process of evaluating a software application to identify its defects and ensure its functionality as intended and verify its needs. So what does it mean? Like suppose there's a software and you're launching a software and there is some defect going on. So what software tester does is it identifies what is the defect which is there, and as soon as the defect is identified, it should be resolved as soon as possible, or else the cost of your product will increase. It will cause lot of several things which goes behind. We'll talk about it later. Let's discuss about its benefits. Preventing bugs and improving performance. As I've mentioned it prevents the bugs. Bugs is nothing but what are the problem, what are the errors which you're getting, ensuring it to be complete. That's all the benefits. And there's one more benefit called as ensuring the software meets the needs. Your needs should be matching with your software requirements, right? That's what software testing is all about. Let's go to the next slide and discuss about the evaluations of software testing. What all they are the evaluations, right? So evaluations of software testing. There are three versions of software testing: 1.0, software version 2.0, and software version 3.0. Let's discuss what are these things. So in software testing 1.0, software testing was just considered as a single phase. You know what is a single phase, right? Software testing was just considered as a single phase. No test organizations were there. These were the initial setups of software testing 1.0 back in 1990s. A few testing tools were present at that time. A few testing tool was present but was limited. Why it was limited? Due to the high cost. Management was not concerned with testing. Initially they do not think testing is a good aspect, but later on this thinking got developed and they came to know about it, like you have to test this. Now coming to 2.0, concept of early testing also started. There was enhancement in testing, we can say that testing was evolving in directions and planning testing resources. Now how they were testing, they were planning all these resources, this all you have to do, and there was a proper plan of the software testing. Many testing tools were also available in this phase. You can see over here it's mentioned many testing tools were also available at this phase. Due to the cost was getting reduced, so many people were able to afford it. What is the latest one is software testing 3.0. It has evolved in the form of the process. We can call it as a process, and it gives a roadmap to a overall testing process. Like in earlier we were discussing, they were planning, and coming to over here it becomes a roadmap. Like roadmap, you have to do this, after that you have to do that, and all those things. Here management is actively involved. The management people were actively, like, to complete any task we need a proper management, right? So software testing, the management was very involved in this. Let's go and discuss the next slide, which is the goals of software testing. So you might be thinking, okay, I understood what is software testing. What do you mean by goals? Okay, let's discuss it. There are particularly three goals of software testing: immediate goals, long-term goals, and post-release goals. What do you mean by immediate goals? Immediate goals is just you're going, is there any bug right now, or how to prevent that. Immediate goals comes like bug discovery, bug prevention. So what is bug? Nothing but some errors and that cause delays in your or some syntax errors. Like we'll discuss it later about bugs in detail. Okay, that is immediate goals. Now coming to long-term goals, like we'll think long-term goals. What is it? Reliability. Your software system should be reliable. Then only people are going to use it, right? And you obviously, if you have to think about the quality, your quality should be your priority, right? In software, you need to have a good quality system. You must be, whenever you go to a laptop shop, you choose a high quality laptop, right? So what is that? The quality, right? User satisfaction. If your system is reliable, if it have high quality, the user satisfaction will be high. If the user satisfaction is high and all those three things are maintained, your risk management will be low, right? There should be least risk management. Right? These all are long-term goals. If you want to make your customers, these all things should be your priority. Now, post-release goals. What are your post-release goals? Reduce maintenance cost. Obviously, you're buying a new car. Suppose you're buying a new car and you're getting maintenance in its second and third month. You must be really upset. Why did I buy that car? Similarly goes with the software system as well. You should reduce your maintenance cost. Your maintenance cost should increase after like 2 years, 3 years, because some people are extensively using that thing. So it is a system, right? It can have some issues, but not initially when you buy it, right? Improve testing process. Improve testing process. In this, your testing process should be improved. Like your earlier version and your current version should have something more, right? Or else why would you sell it, right? Bug prevention. Bug prevention, as I have mentioned, we'll discuss it later. Bug prevention. Let's go to the next slide. Goals of software testing, customer satisfaction. So I've said you, right? Software testing, it goes to the reliability. If your system is reliable and have a good quality, your customer satisfaction will be high. That's what we have discussed earlier as well. Let's lower risk management. Software testing is controlled by risk factors such as cost, time, resource, critical features, like how much money have you take to make it, what is your time, what are your resources, and after all this critical analysis, if your customer satisfaction is high and your risk management is low, then you are good to go with this system, right? Failure. In software testing, there's a terminology called as failure. Let's discuss it. What is it? Failure. It occurs when the software doesn't perform intended functions, unexpected results, often due to unintended defect of errors. Failures. Failures occur when you, like, suppose you are doing coding, right, and your system suddenly shuts down. That's a failure, right? You're doing some task and your system suddenly erupts. That's hilarious, right? So why did this happen? Because there were some errors going on previously. That errors converted into defects or bugs that result in failure. Now, types of failures, there are particularly three types of failures. Functional failures, which I've discussed now, your functionality completely failed. Performance failures and security failures. Security failures, like some unauthorized people came in, like you clicked something and all, and some unauthorized got your system all details and he manipulated all the data and all. Functionality failures perform when a specific function is, like, you want to print hello, but world came. You don't know how. That's something, your functionality failure, that we're talking in the concept of syntax, but just an example to analyze it. And performance failure, which I mentioned it before, your system performance failed. That's what about failure is. What do you mean by fault? Fault is a condition that causes the system to produce failure. See, failure is the last step. The previous step is called as fault. Fault fault causes system to produce failure. So you need to resolve as soon as you see some fault. You need to resolve, or else your system is going to fail. Fault is a reason embedded in software design and result in failures. As you can see in this diagram, there is an input and there is a bug. Bug is nothing but some errors. And if these bugs keep on increasing, your system will get overload, and at last it will cause failure. When bugs is executed, then failures are generated. That's what it's mentioned. I guess you come to know what is a bug. What is an error? Error are nothing but human mistakes. It might be a typographical error or a misleading specifications, a misunderstanding of what subroutine to an like it's just general. Error causes bugs and bugs causes failure. Errors are human mistakes. That's it. You can understand. Error causes a bug. Right. That's what error is. Now let us discuss the most my favorite topic. What are the different types of bugs? Right. Okay, let's go to bugs. What are functionality bugs? So functionality bugs refers to the defect or a issue in software application that affect their intent functionality. Functionality bugs, you can understand that it is just affecting your functionality. You're not able to perform what you want to perform. What if you want output as X, you're getting output as Y. That's what functionality failure is, which we have discussed, and this is a functionality bug. You're getting the wrong functionality. Now, logical bugs. Okay, let me ask you a very simple question. Do you know logical bugs are common in software development and can be challenging to identify and fix it? Do you think like that? If no, let me give you some fact. Unlike syntax errors, which are relatively easy to spot during the violation of the programming language rules, logical bug occurs when the code does not produce the expected output or the behavior. Like if you remove the syntax errors and all. Like syntax errors, if you're telling that is a logical error, that I don't think that is a logical error. Suppose you are doing summation of two numbers x is equal to a plus b, but your output is coming x is equal to a into b. So there's some logic that you have wrote some that is not working, right? That's what logical error is. Logical bugs. What is the next bug which we are going to talk about is workflow bugs. What is a workflow bug? This bug can be a major hindrance to the productivity. Remember this line, the productivity and the efficiency in any organization. This bug is major hindrance. This bug refers to the glitches. What are the glitches you're getting? What are the errors or the bottleneck with the workflow process? Whatever bottleneck causing delays, confusion and frustration. That's what you're getting, some glitches in the system, it's all caused to the workflow bugs. Your system is getting blacked out. It's all due to the workflow bugs. Coming to the next thing is unit level bugs. It refers to the defect or the errors at the smallest testable component. Smallest testable component in a software system. That's what the name suggests, unit level bugs. Like small unit, if there is something error, this unit level bugs. Now talking about system level integration bugs. It refers to the issue that arises when the different components of a subsystem, complex system fails. It completely fails to work together. Two systems are not able to work together. Their collaboration is getting failed. This bug can occur. These bugs are called as unit level bugs. And it can occur for various reasons such as incompatibility interfaces, or your miscommunication, or inadequate testing, your testing fail, all this. As a software engineer, we heard a lot of times out of bond, out of bond. So let's discuss what is out of bond bugs. Out of bound bugs occurs when the logical and the arithmetic error exceeding the allowable boundaries. The one which you have read in your coding, it's the same. When it is exceeding the boundary, then only we say out of bound bugs. Now, talking about security bugs, these are persistent and considering issues in the world of technology. These bugs refers to vulnerability and flaws in software hardware system. Like the name suggests, your security, some flaws are coming unauthorized, people are trying to steal your data. Software bugs are all about. These are all your different types of bugs. Now, what is the life cycle of a bug? So your life cycle is divided into two phases: bug in phase and bug out phase. In bug in phase, when errors are human mistakes, as we have mentioned, in any point of time you will have. As soon as you'll have an error, there will be a bug, right? The requirement gathering specifications. Once you will gather all the requirements specification, then that will, if there's an error, it will create a bug. Then you'll design it, then you code it, and you send for testing. If the testing people are unable to find the bug, then it will lead to the failure, right? Classify the bug out first, like classify the bug, isolate the bug, and resolve the bug. That will cause a failure, and then you will classify it. Okay, this is my bug. Then you'll isolate the bug, then you'll separate the bug and resolve it, and again send it for testing. So over here, see this bug out phase. There are situations when bugs are present even though we don't observe the failures. That's what bug out phases you saw here in the previous slide. Bug out phase, that's what happened. In this phase we observe failures. Here you see the failure. We classify bugs according to the nature. A bug can be critical or catastrophic in nature. Thus bug categorization or bug help in handling highly critical bugs. Bug classification, classifying the bugs according to the nature, which we discuss in bug out phase. A bug can be critical, right? Bug isolation. What do you mean by bug isolation? It is the activity by which we locate the model where bug appears. Wherever bug appears, we know here is the bug. We'll isolate the bug for the further testing or resolution. Now, bug resolution. Once we locate this bug, once we locate the bug, we'll isolate it and we'll resolve it, and again we'll send it for testing, so that it's nothing else that is present, right? Now, states of a bug. States of a bug. There are different states of a bug. It coming to new. What is new? This is the initial state of a bug, first identified and reported by a test. Over here, the first identification of bug is seen over here. That is new, right? Now, what do you mean by open? The bug is actively being worked on by the assigned developer. Open. Now, it has been identified. Now, it will be start working. It is open to work, you can say that. Now, assign some tester. In assign, some tester have start working on it. That is nothing. The word assigned, you give it to someone, right? After assign, you see test. Now you're testing on it. Now you're testing on it. Now your bug is getting tested. After testing, you see it's verified. Do you see that? It's verified. If the retest confirms the bug is fixed, if the after testing it is reopened. Why it is reopened? Let's not talk about verified right now. Let us talk about reopened. It is reopened. It is reopened and again assigned to check whether the bug is fixed or not. If it is fixed, then we'll verify it like pakka it is fixed or not, and as soon as we'll say yes it is fixed, then we'll close the bug, the last step. So coming from new to open to assign to test, then reopen it to check whether it's going bug is resolved or not. After doing that, we'll go for verification and then closing it. Right. Now, how does bug affect economic of software testing? If you see, if you identify a bug in specification phase, the cost is very low. Coming to low level code, unit test, integration test, system test, post delivery, the cost of debugging is getting increased and increased. So after delivery, it's not at possible or to say like we'll resolve it because it's too late. Bug classification based on criticality. Okay, now we are going to talk about the bug classification based upon criticality. Major bug, it does not stop the functionality of software. Okay, there are three major bug, medium bug, minor bug. In major bug, it does not avail the stop of functionality. It does not stop the system. It causes some functionality to fail, some functionality like you are typing. It does not shut down your system, but it restricts you to type. That is your functionality. Medium bug, they are less critical. They're less critical, right? If the output are not according to the standards. Example, a redundant or a truncate output, that a bug is the medium bug. From the, as we've discussed earlier, it's not like you're getting your output, but the output which you are expecting, you're not getting that. So there must be some logical error, something like that, which we have discussed before. What is a minor bug? These are just mild bugs. Occurs when, like, if you're not expected to do this software thing, like some human errors you can talk about over here, like typographical errors. Suppose I'm typing my name Hardik, I'm not getting, like if I'm typing H, I'm getting G. That is, so by mistake I am typing G instead of H. That is, you can take an example if you want. That's a classification on critical. The most critical bugs are the major bugs, and the least one is the minor bugs. Minor bugs are nothing but your errors, and major bugs is your functionality failure and all. So that's all about software testing. Thank you everyone.